Hello everyone, and welcome to this live session on Introduction to Hadoop. I'm very glad to see you all joining this session, and that is why I'll make sure that you take away a good amount of knowledge today about Hadoop. So my name is Reshma, and I will be taking you through the basic concepts of Hadoop and help you get started with this technology. So let us see the agenda, the things we're going to learn today. So first we'll see why Hadoop exists, just to make sure and understand that why Hadoop this technology came into existence on the first place. Then we'll get introduced to Hadoop, we'll understand what is Hadoop and its different components, and finally I'll be showing you a demo on Hadoop. Alright, so looks good, and let us get started. So first let us know how Hadoop came into existence. The reason is big data. Now what is big data? So big data is nothing but it's a term that is used for a collection of data sets that are very large and very complex data, and it is difficult to store and process using our available database management tools or our traditional data processing applications. And the challenge that is included that comes on with big data is that the capturing of the data, since I told you that it is very large and complex, so it includes problem in capturing the data, curating the data, storing it, searching, sharing, transferring, analyzing, and visualizing. And there are other also related problems to it. And as you know, that big data is getting bigger every day. The quantity of data on planet Earth is growing exponentially for many reasons. Some of the reasons that we come across in our day-to-day activities. For example, now everything is online, right? Every single thing that we do leaves a digital trace. Now with smart objects going online, the data growth rate has increased rapidly. It includes uploading a photo on Facebook. Everyone is doing that when you make a tweet on Twitter, right? It is also contributing to big data. With smarter devices, with cell phones, it is contributing more and more to big data. But we have to understand, what is big data? Can we refer every data as big data? Well, there are certain criteria in order to identify what is big data, and these are called the 5 V's. So let us get started with the 5 V's. Now the first V is volume. Now volume refers to the amount of data that is growing day by day at a very fast pace. Now the size of data generated by humans, machines, and their interactions on social media itself is massive. And researchers have predicted that 40 zettabytes will be generated by 2020. And this is increase of about 300 times from what we had in 2005. Then comes variety. Now, as there are many sources which are contributing to big data, the type of data they are generating is different. Now, it can be either structured data, semi-structured data, or unstructured data. Well, actually, 90% of the data generated are unstructured. For example, like your images, videos, your audio files, these are all unstructured data. And hence, there is a variety of data which is getting generated every day, all kinds of different data. And earlier, we used to get the data from Excel and databases only. But now the data are coming, like I told you, there are images, a lot of unstructured data. And that is why, because of the unstructured data, it creates a problem in capturing, storage, and eventually analyzing the data. Next comes velocity. Now, velocity is defined as the pace at which different sources generate the data every day. Now, this flow of data is massive and it is continuous. And there are almost, in Facebook, there are 1 billion active users on Facebook every day. And with mobile, there is an increase of 22% year over year. So this shows that how fast the number of users are growing on social media and how fast the data is getting generated daily. Right? So you have to handle velocity, you have to handle how fast the data is coming, and you have to handle, in order to store the data coming at this huge pace, in order to handle big data. So this is also one of the major problems associated with big data. Then comes value. Now, everything aside, even if you are able to handle big data, if you're able to store it and process it, but it comes to no use if you cannot take out value from the data. Now, what I mean by value is adding benefits to the organization who are analyzing big data. So it means that whether working on big data, is your organization able to achieve a good ROI? Right? So unless it adds to the profits by working on big data, it is useless. So you have to make sure that the data you're handling also gives you a certain value in terms of your organization profits after analyzing it. Then comes veracity. Now, what is veracity? So veracity refers to the data in doubt or uncertainty of data that is available due to inconsistency and incompleteness. Now, the data that is available can sometimes get a little messy, and maybe it is sometimes difficult to trust. Like with many forms of big data, quality and accuracy are difficult to control, like Twitter posts with hashtags, abbreviation, typos, and colloquial speech. So the volume is often the reason behind the lack of quality and accuracy in the data. So these 5 V's lead to the big data. So this is how you can identify what is big data. All right. So now let us understand the major problems. Now, if I have to simplify it to you, so there were actually 2 major problems with big data. So the first one was to store the big data, right? Because there is humongous amount of data in front of us, and if we are to use traditional systems, we are using our traditional servers in order to store the big data, it will cost us around $25,000 per year for each TB. Now, I've already told you that we are not dealing with just terabytes of data, not even, I mean, we're dealing with zettabytes. Like I told you, by 2020, there would be 40 zettabytes. So this is completely unfeasible in terms of cost if we are to use traditional systems. The second problem was to process the big data. Now let's just assume that, okay, you have found out a solution and you do have the money to afford all the necessary hardware to store data. In order to process it, you need to copy all the data into the compute cluster, and then after processing, you have to write back the processed data into the storage cluster, which is a massive task to handle. So that is why it is also, you have to make sure that the compute cluster also has the ability or also has the capacity to store the big data. So hence, it needs very high computing power and also storage power. And it is it is a very big problem in terms of cost. All right. So how did Hadoop solve that problem? So with Hadoop, you get HDFS, which is the storage unit or the storage component of Hadoop. So it helps you to store your files in a distributed manner, and it can help you to cut down the cost from $25,000 to around $1,000 to $2,000 per TB per year. So you can see the drastic amount of change and the cut in cost with Hadoop. And in terms of processing, Hadoop has Yarn. So with Yarn, you can process your data parallelly. So it doesn't necessarily mean that you have to copy all the data into your compute cluster. You can actually process the data parallelly in different machines. Okay, and in case you need more computing power, all you have to do is just include more units or include more machines in your cluster, and it is known as horizontally scalable, because if you want to increase the compute power, just add more machines. Hence, it is horizontally scalable. So we'll talk more about HDFS and Hadoop Yarn in the coming slides, so don't worry about that. So I'll be explaining how exactly parallel processing happens and what is the distributed storage. All right, so basically Hadoop has solved the main problem associated with big data, which is to store the big data and process it. So now let us understand what exactly is Hadoop. So Hadoop is nothing but it is a framework that allows us to store and process large data sets in parallel and distributed fashion. So for storage, Hadoop has HDFS. Now within HDFS, you can dump any kind of data across the cluster, be it structured data, be it semi-structured, be it unstructured. HDFS can handle all kinds of data. You just dump it and it will be stored in a distributed manner across your cluster. All right, so Hadoop also involves different machines which forms a Hadoop cluster. And the best part about this is that Hadoop uses commodity hardware. Now, by commodity hardware, I mean that the simple laptops or desktops that you use at your home, right? The simple ones, very cost effective, very low cost systems. So that is why it is able to cut down the cost. You don't need high-end servers and all those costly servers in order to set up a Hadoop cluster. All right. So HDFS. HDFS is a storage unit, and whenever you dump data, your data is distributed across all the different machines present in the cluster. All right, then for processing, you have YARN. So YARN stands for yet another resource negotiator, and it allows parallel processing of data in HDFS. So whatever data is stored in your HDFS, it will be processed parallelly, and finally, it will aggregate, and finally you get the aggregated result at the end, of course. Now, it is not just HDFS and YARN that makes the entire Hadoop ecosystem. There are many other tools. So these are just the major ones that is widely used across. Now, you can use one of them at one time, depending on the job you're performing or depending upon the big data analytics you're doing, or you can choose multiple of them at once. All right, so let us talk about all these different Hadoop ecosystem tools one by one. So first, let us talk about MapReduce. So MapReduce is nothing but it provides the logic of processing. So in other words, MapReduce is a software framework which helps in writing applications that processes large data sets using distributed parallel algorithms inside the Hadoop environment. So as the name goes, it is map and reduce, right? So it has two functions that is called map and reduce. What the map function does is that it performs actions like filtering, grouping, and sorting, while the reduce function aggregates and summarizes the result that is produced by the map function. All right, then let us come to PIG. Now, PIG is a scripting tool. All right, and PIG has two parts, which is PIG Latin, the language, and PIG Runtime, which is the execution environment. So you can think of it like in terms of Java. For example, Java is your language and JVM is your environment, right? So it is the same as that, PIG Latin and PIG Runtime. So, and PIG Latin is a language that is very SQL-like. It has a complete SQL-like command structure. So if you're already familiar with SQL, you will have like no problem to get started with PIG. You can write all of the PIG Latin queries and the commands very easily. And there's something you should know that PIG is a very, very powerful tool, because if you want to tell me in that way, 10 lines of PIG Latin is approximately equal to 200 lines of MapReduce code written in Java. So what you can do with 200 lines of code, you can do the same with PIG in just 10 lines. But the catch is that whenever you write a PIG command, there is actually a MapReduce job that is happening that gets executed at the backend. All right? So each of the PIG query that you write, each of the PIG command that you write, it is actually translated into MapReduce code, and hence it gives you the result. And PIG was also developed by Yahoo, I must tell you. All right, it gives you a platform for building data flow for ETL and processing and analyzing huge data sets. Then next comes Apache Hive. Now, Apache Hive is also a very powerful analytical tool. It was created by Facebook for their employees who were fluent with SQL. And again, this is a SQL-like language. It uses a language called HQL, which is known as the Hive query language, which is completely SQL-like. Okay, then comes Spark MLlib and Mahout. So these are actually renowned for machine learning. Now, Mahout provides with you an environment for creating machine learning applications which are scalable. So Spark MLlib and Mahout they are used for machine learning tasks such as collaborative filtering, clustering, classification, all that tasks that you need for analysis. And it has got inbuilt algorithms available in their library, for example, like k-means, that is widely used for analysis. So you can find all this machine learning algorithms available in Mahout and Spark MLlib. Now let's talk about Spark. Now I'm very sure you already have heard about Spark. This is a very popular tool that is used for real-time processing. Right? This is also a framework for real-time data analytics in a distributed computing environment. Now, Spark is written in Scala, and it was originally developed at the University of California in Berkeley. So it executes all in-memory computations to increase the speed of data processing over MapReduce. It is almost 100 times faster than Hadoop for large-scale data processing, and it is widely used across all different industries, right? Now let's talk about another tool, which is HBase. Now HBase is an open source non-relational distributed database, or in other words, it is a NoSQL database. It supports all types of data, and that is why it is capable of handling anything and everything inside the Hadoop ecosystem. Because NoSQL essentially doesn't mean not SQL. It actually means not only SQL. It can handle everything. Then comes Zookeeper and Ambari. So these are management and coordination tools. So Zookeeper is the coordinator of Hadoop job, which includes a combination of various services in a Hadoop ecosystem. Now Apache Zookeeper coordinates with various services in the distributed environment. Because before Zookeeper, it was very difficult and time consuming to coordinate between different services in Hadoop ecosystem. The services earlier had many problems with interactions like common configuration while synchronizing data. Even if the services are configured, changes in the configuration of the services makes it very complex and difficult to handle. And that's why we use management and coordination tool like Zookeeper in Ambari in order to make sure that all the different tools, different Hadoop ecosystem tools that you're using at once are coordinating properly and are properly orchestrated. Now let's talk about Oozie. So consider Apache Oozie as a clock and an alarm service inside a Hadoop ecosystem. So for Apache jobs, Oozie has been like a scheduler. It schedules Hadoop jobs and binds them together as one logical job. All right, so you'll learn different things about Oozie, like Oozie workflow and coordinator. So you'll learn about all the Hadoop ecosystem tools as a part of the course curriculum. Then let us talk about Flume and Scoop. Now these are data ingestion tools. So if you want to ingest data into your HDFS, you use either Flume or Scoop. Now Scoop is used to ingest structured data into the HDFS, and Flume is used to ingest unstructured or semi-structured data. Unstructured as in images, your video files or audio files, semi-structured like JSON files, XML files, etc. And structured data, as you already know, that can be easily represented as rows and columns, for example, like the tables you see in SQL, right? So for structured, you use Scoop. Unstructured and semi-structured, you use Flume. Then there are different tools for searching and indexing, which is Solar and Lucene. All right, and there for streaming, we have got Storm, which is also a real-time processing tool, and Kafka, which is a pub subsystem. All right, so you will learn all about that as a part of the course curriculum. So these are the Hadoop ecosystem tools, and let me tell you that these are not the only ones. There are many other tools that are getting contributed to the Apache Foundation and are becoming a part of the Hadoop ecosystem and are being used for big data analytics purpose. So now let us talk about the components, the main component, which is HDFS. So HDFS stands for Hadoop Distributed File System. And the best part about it is that it creates a level of abstraction over the resources, and you can actually see HDFS as a single unit. Now, if we talk about the architecture of HDFS, it is a master-slave architecture. As you can see, so the master is known as the name node, and the slave nodes or the daemons are the data nodes. All right. So these are the daemons included in HDFS. There is the name node, which is the master node. There is secondary name node and the slave nodes, which are the data node. Now we'll talk about each of the component, each of the daemons one by one. All right. So first let us talk about the name node. So NameNode is the master daemon that maintains and manages all the data nodes, which are the slave nodes. So what it does is that it records the metadata of all the files stored in the cluster. For example, the location of the blocks where it is stored in each data node. Now don't worry, I'll tell you what blocks are. All right. The size of the files that is stored in the HDFS across the different data nodes, the permissions, hierarchy. All right. So everything is managed by the name node. And it also makes sure that all the data nodes are running, so it receives a kind of signal which is known as heartbeat from all the data nodes. So if it receives a heartbeat from each data node, it means that that data node is working and is alive. Now let us talk about the secondary name node. Now most of the people get confused with the name secondary name node. They almost assume that it is used, it is like a name node that is, sorry, so most of the people actually assume that it is the name node which is that will be used if the name node goes down. Well, it actually has a different purpose. It is used for checkpointing. All right, so what is checkpointing? So it is a process of combining edit logs with FS image. Now, what are edit logs and FS image? So these are the kinds of metadata that are managed by the name node, right? So this was what I told you, that the name node manages certain metadata. So edit logs and FS image are the kind of metadata that was managed by the name node. So it performs a task called checkpointing, which means adding up the edit logs with FS image. Okay, so let us see how exactly it happens. Okay, what the secondary name node exactly does. So FS image is a file that contains all the complete state of the file system since the starting of the name node. So if you have set up the name node years ago, the FS image will contain the metadata about all the different transactions that happened ever since the name node was set up. And edit logs, on the other hand, it contains the recent modifications that you made to the file system. All right. For example, something that you did just hours ago, whereas FS image will store the transactions that you did maybe weeks ago. All right, so what it does is that it performs checkpointing. It means that it adds up edit log and the FS image and finally makes an updated FS image. And this FS image is then copied again to the name node. This is just to make sure that the name node is always updated with all the transactions. The FS image contains all the newer transactions. All right, so let's say that if a name node fails, all right, so all the metadata will not get lost. The secondary name node has it. So if you want to set up a new name node, the FS image from the secondary name node will get copied to the name node and all your data will be preserved. All right. Now let us talk about the data nodes. So data nodes are slave daemons or processes which run on each slave machine. So this is actually where all your data is getting stored. So whenever you dump any kind of data into HDFS, your data is actually going into the data node. All right, so it performs all the low-level read and write requests from the file system. All right, and as I told you that the data node sends heartbeats to the name node periodically to report overall health of the HDFS, and by default it sends heartbeats every 3 seconds. All right. So this is the complete HDFS architecture. Now let us talk about HDFS block and replication. Now I told you that every file is stored in HDFS as a block. Now what are blocks? So blocks are nothing but the smallest continuous location on your hard drive where your data is stored. So in general, of any of the file system, you store the data as a collection of blocks. So similarly, HDFS stores each file as blocks which are scattered through the Hadoop cluster, and by default the size of each of the block is 128 MB. Alright, so if you, let's say, have a file of 380 MB, so it will get divided into 3 blocks. So the first one will so the first block will be of size 128 MB, the second one will also be 128 MB, and the third one will occupy whatever remaining is left, which is 124 MB. So there is a problem in front of you. So just tell me that if you have a file of 500 MB, how many blocks will be created? So it's a very easy question, so you can just quickly type down the answers. All right, so yeah, of course, it will get distributed into 4 blocks. The first 3 will be of 128 MBs, and the fourth block will be of the remaining, which is 116 MB, right? So this is how your data gets divided into blocks and is distributed across the cluster. Now let us understand how exactly it is distributed, right? So again, we'll consider the same example. Let's say that you have a file of 380 MB, so it gets divided into 3 blocks, and it will now get distributed across the cluster. All right, so your first block will go to data node 1, your second block will go to data node 2, and third block will go to data node 3, assuming that we have got 3 data nodes in our cluster. Okay. Now it also replicates your data blocks, and that is why it is fault tolerant. This is one of the most beautiful features of Hadoop, that it is completely fault tolerant. Now your data and your replication factor here is 3. So it means that your data blocks, each of your data block will have 3 copies in across the Hadoop cluster. All right, so your first block will get copied in data node 1, 2, and 3 as well. Then your data block 2 will also be across all the different data nodes. So now let's say that if a data node stops functioning, you don't have to worry, your data will not be lost because there are replicas of it. There is a replica of your data in data node 1 and data node 2, right? So your data will never be lost, and you have certain criteria in order to replicate your data also, right? Because you'll not just exactly be having 3 data nodes across your cluster. You'll have more, so there are certain other factors. So that is also covered as a part in the course curriculum. So you'll understand how data is exactly replicated and how exactly it is distributed. So, but basically, the main point to take out from here is that it is completely fault tolerant. Alright, so I hope that you have understood how data is separated into blocks and distributed across the cluster. Right, so these are a few Hadoop commands. So if you already have a Hadoop setup, so then you can just run this commands. Okay, to check the HDFS health, you use this command. To check the version of Hadoop, use Hadoop version. Alright. So we'll also be performing some of these commands when I'll be showing you the demo. Alright. Now let us talk about Yarn, the processing component of Hadoop. So when Hadoop came up with its new version, which is Hadoop 2.0, so it came up with a new framework which is known as Yarn. Now, Yarn stands for Yet Another Resource Negotiator. Now, it provides the ability to run non-MapReduce applications. And Yarn is the framework that is responsible for doing cluster resource management. So Yarn again has a master-slave architecture. So the master daemon here is called the resource manager, and the slave daemons are the node managers. All right, so we'll talk about each of the daemons one by one. So first, let us talk about the resource manager. So as I've already told you that Yarn is responsible for cluster management, right? And it is actually, it behaves as a pure scheduler. Now, it is strictly limited to arbitrating requests for available resources in the system that is made by the competing applications. So it optimizes for cluster utilizations, that is, it keeps all the resources in use all the time against various constraints such as capacity guarantees, fairness, and service level agreements. Right? And it also manages all the node managers. So whatever request comes from the client for any job execution, it passes the request into the respective node managers. All right. Then let us talk about the node manager. Now, node manager is the slave daemon in Yarn. So node manager is installed on every data node. This is how your data gets processed in your data node, because I have told you earlier that Hadoop allows parallel processing of data. So this is what makes parallel processing. Now your data node are different machines, right? And your data is stored there. Now so you don't have to move your data into a different compute cluster, right? So your data gets processed where it is stored. Now there is also a term for it. This is known as data locality, right? So that is why Hadoop is also very efficient, because data gets processed where it is present. And hence you should know that in each data node, a node manager is also present. And node manager is what is responsible for execution of tasks on every single data node. So this is the master-slave architecture. So this is the complete architecture. So there are different other components also involved with Yarn. So let us understand it better with a workflow. So what happens is that first a MapReduce code is turned into a job, and that job is submitted to the resource manager. Okay, so the resource manager receives the job that is submitted by the client, and it sends the client an application ID for that particular job. After that, the resource manager contacts the node manager, associated node manager, and starts a container. Now, what is container? So a container is a logical bundle of resources, that is your memory cores, that is bound to a particular cluster node. So to enforce a task such as assignments that is given to by the resource manager from the client, so it interacts with a node manager, all right? And the communications between the resource manager and the node managers are also heartbeat based for scalability, all right? So after that, there is an app master involved. Now, what is app master? This is the application master, and this is an important concept in Yarn. Okay, so application master in effect is an instance of a framework specific library and is responsible for negotiating resources from the resource manager and working with the node managers to execute and monitor the containers, the resource consumption, etc. So what its main responsibility is to negotiate for appropriate resources, the containers from the resource manager, and track their status and monitor the progress of the jobs. All right, so after the app master request for the resources required to execute the job from the resource manager provides it. Then the container is started, and finally your job is executed. Okay, so this is how exactly it works. So if you want to see it step by step, so first the client submits an application to the resource manager, then the resource manager allocates a container to start the app master, then the app master registers with the resource manager and asks containers from the resource managers, which are basically the resources required to execute your job, because your job is actually executed in a container, right? Then the application master notifies the node managers to launch the containers. And finally, the application code is executed in the container. Then the client contacts for status. And once the job is completed, the app master unregisters with the resource manager. All right, so it's very simple. So this is what it looks like, HDFS and Yarn together. All right, so the master daemons are secondary name node and name node in HDFS. In Yarn, it is the resource manager. Then the slave nodes in HDFS are data node, and in the Yarn, it is the node manager. And you know that node manager and data node resides in the same machine, but it doesn't necessarily mean that the name node and the resource manager will also be in the same machine. They can be, but they usually reside in different machines. All right. So now we have come to the demo part. Okay, so this is what we will be doing today. So we are dealing with a crime dataset today. So we have collected two datasets, which is the crime year and crime age. These are CSV files. Okay. And so this actually contains crime against women. So there are the different states of India and the crime details about it. For example, what is the crime? Then who are the victims and who are actually also the people who have assaulted the women. Okay, so it contains data like that. All right, this is the crime age, so it contains the data of the perpetrator and the victim. All right, so usually, so in our data set, our victim are the females. And then we have another data set over here, which is a crime year.csv. Now it also has the different crimes that, which is the crime head in the section crime head, and it contains the data across a number of years from 2001 to 2012. All right, so we're going to use this data and we're going to find out this. So first we'll find out the total number of crimes which occurred in all states in the year 2006. Okay, so we'll be just analyzing 2006. After that, we'll calculate the number of females that are aged between 18 to 30 years who were victims in different crimes in different data sets, in different sorry, states. Okay, I'll just have some water, so we'll just take a few seconds of break. Okay, so let us come back to the demo part. All right, so I hope that all of you can see my screen. So I've started my VM. So my VM already has Hadoop and everything installed. All right, so and of course I'll be telling you that we're going to do this in PIG. All right, so I've already given you an introduction about PIG, what it is, a scripting tool, right? So we'll be making this analysis using script commands, okay? PIG commands, I'm sorry. So my screen is visible, right? So you're able to look at a VM. Is it correct? All right. So first, let us check if all our daemons are running. So for that, you use this command, right? Sudo jps. It's asking for password. So yeah, all my daemons are working. Name node, secondary name node. So also my data nodes are working. My node manager, resource manager. So perfect. So we'll be using pig. So we'll have to get into the grunt shell. Now pig uses the grunt shell. All right. So first we're going to find out the crimes that occurred across different states in 2006. All right. So the first thing that I'll do is that I'll load the dataset. So now I've already copied the datasets that I've shown you into my HDFS. All right. Now I have to load it in pig storage. So for that, I'll use this command. So I'm using a variable called x, and in order to load it, I'm going to type load. I have to also provide the path now, which is HDFS localhost 9000, the name of my dataset, which is crimeyear.csv. Okay, and after that I have to write using pig storage, and our file that we have, the dataset that we have, it is comma separated. The delimiter is comma. So that is why I'm going to mention that as well. And just like how you end SQL commands, you also end a pig command with a semicolon. All right. So now, if you want to see how the data is loaded, you can just type dump x, since I am using this variable x. Now it takes some time. So yeah, so here you can see, so this is how my data looks like right now. So we're going to just arrange it and refine it a little bit more in order to find out the total crimes for all the states in 2006, right? So now it is very scattered. It doesn't give me any clue. So this is just the raw data, right? So the next thing I'm going to do, I'm going to use another variable y. Okay, and now I'm going to use for each x. So we're going to just scrape out the columns that we actually need. So since I told you that my dataset had crimes across different years, right, till 2000, 12, right? But I need only for 2006 now. So that is why I'm going to only pick out the columns that I need. Now first I'm going to do typecasting also here. So I'm going to choose a character array $0. So it means that it will pick up the first column. $0 represents the first column in my data set, and which was state, right? So as state, and then I'll need the year also. So 2006 was the 8th column, right? So I will take that as well. Sorry. So it will be $7 since it was in the 8th column as year, okay? So now if you want to see how y looks like, so you can use dump y. So now I've only picked out state and the year, which is 2006. So here you can see now it has only picked out the states and the crimes in 2006. All right, but then we have got multiple entries for each of the state, right? So we want to collaborate each state together, right? For all across all different crimes that is present in our data set. Right, so now what we'll do is I'm going to use, okay, first let me just clear the screen. So I'm going to use another variable. So I'm going to use Z, and now I'm going to group by state. So group Y by state. And then let us see what Z has. So here you can see, so I've got the data of all of my states at one place. So for Uttar Pradesh and for Andhra Pradesh and all of the different states. So you can see that it is actually forming an inner bag for each state. So for Uttar Pradesh, we have Uttar Pradesh, then we have got this pair, right? So it will first contain the name of the state and then the number of crimes. Okay, this is for different particular crimes. Now I don't want the data of different crimes separately. I want the data of the number of crimes all across different crimes, all right, for each state. So I have to sum up all these numbers together for each state, all right? So I have to sum up 520, then 00 plus 34720, then all other that is associated with Uttar Pradesh, and I want to see it together like Uttar Pradesh and the total numbers. So I will have to perform a sum operation now. All right. So that is what I'm going to do. I'm going to take one more variable. I'm going to call it as, let's say, data1. Okay. Now, so I'll do for each Z, I'm going to generate a group. I'm going to use the sum function here. So I'm going to use y dot here. All right. And now this is my final result actually. So I'm going to write it back into HDFS. So now I'm going to store data1 into HDFS. So I have to also provide the path of it. All right, so I'm going to put it in user Edureka, and I'll just name this file as output1. All right. So it is creating output 1 in HDFS, and this is where all the data is going to get stored. And it's a success. So if you want to see how the final result looks like, you can use the web UI of to view your HDFS at once. All right, so you can just go to localhost :50070 and you can explore your HDFS directory. All right, so it is in user Edureka, right? So it has created output 1. So if you want to see how it looks like, so this is where you can see. So I'm going to download it and show it to you. So this is what it looks like, right? So these are the total crimes across different states of India in 2006. So if you want to sort it, also you can sort it. You can use an order by whether descending or ascending. All right, so this is how you can find out which state has the most number of crimes against women, right? So this completely gives you a clear picture. All right, so we have done our first analysis. Now let us move on to with our second, right? So now we're going to find out how many of the victims across different states were ranging from the age 18 to 30, right? So if you remember in our different data set, which is the crime age, we had a column for that, right? So I'm going to, in this particular thing, I'm going to use the second data set, right? So for first thing, again, I'll use a variable and I'll load the data set first into PIG storage, right? So it is also there in my HDFS. So I have to provide the path and the name of my data set is crime age. If you remember, we did using PIG storage. And again, it was a comma separated file. All right. So I'm going to mention it. Okay. Then we'll do the same thing that we did earlier. So we're going to pick out the columns that we only need, right? So we don't want all the age groups. We just want the state and the age group, the column that contains the age group of 18 to 30, right? So for each A, you have to generate So I'm going to choose the character array. So state is a character array. So it was in our first column. So it will be, we'll be using $0 here. Okay, so we'll put it as state. And after that, int, that was in our sixth column. So we'll be using $5 as age. All right. So after that, again, we don't want for different crimes, we don't want like different numbers for each state. We want to accumulate together for every state. So yeah, so we'll again use group by. Okay, group B by state. If you want to see how C looks like, so you can use dump C. So here is it. So these are the number of victims across different crimes that ranges, whose age group is between 18 to 30 years, right? But now it is separated for each crime, but I want the total number, right? So again, this is that inner bag involved. So again, I have to sum all these numbers up, okay, which is the second value, right? So I have to do a sum again. So I'm going to use another variable. So let's call it data2. All right, so I'll use for each C, generate group. Then I'll do the sum, I'll use the sum function here, which is dot age. Right, so this will give my final output. So now again, I'll just store all this, the final output in my HDFS. I'll write it back there. So store data2 into, so I have to provide you with the path. So I'm going to use user/Edureka, a separate file for this to store this data. So let us call it output2. Sorry about that. And so it's a success. So we can go to our HDFS and we can see our second output, which is here, which is output 2. So if you want to see how it looks like, let me just show it to you. All right, so yeah, this is how it looks like. So these are the total number of victims aged from 18 to 30 for each state. All right, so these are the two analyses that we have done using PIG. Now you can do more with these two data sets. For example, there are like different prospects of looking at this. For example, you can also find out that the increase in crime across different states in number of years. So if you want to see that if the crime rate has increased from 2005 to 2012, you can easily do that, okay, using PIG. You can also see that which are the crimes that are getting increased, which are the crimes that are getting decreased. So these are the kind of analysis that you can do with this data set. So you can do more with this. It is also included as a part of the course curriculum that we have at Edureka. So this is also one of the projects that you can do, because in Edureka you can choose to do multiple projects and you'll always get help with your projects also. So this is just one of them. I have just shown you the very basic bare minimum of it because this is just an introductory session to Hadoop. All right, but the scope is a lot. So what you can do with these data sets, all right? Now, I would tell you that since I have done this using a VM in my system, but in Edureka, you have Cloud Lab, so you don't need any system with high RAM in order to run your VM. All you need is just anything that has an internet connectivity, any machine with an internet connectivity, and you can connect to the Edureka Cloud Lab. Now, everything is pre-installed in the Cloud Lab. Okay, whatever software that you need is already configured, and you can just perform all your practicals. Even if you want to practice, you want to complete your project, your assignments, you can do it in the Cloud Lab. And in Edureka Cloud Lab, there is the cloud error distribution. So you know that it is widely used across the industry. Cloud error distribution is the most preferred Hadoop distribution that is used. So we have the same at Edureka Cloud Lab, which is as per the industry standards. All right, so if you want to see more about the Cloudera distribution in Edureka Cloud Lab, what are the features, what exactly is there? So I'll just ask the Edureka team to ping you a video of that. All right, so you can just go through the video if you want to know more about the Cloud Labs, the features of Cloud Labs, and how the Cloudera distribution looks like. All right, and also now let me tell you that there is a counseling session on 17th of May at 7 a.m. So if you want to consider big data as a career prospect, all right, so you must attend this session because it will take you through the most basic question that whether you can make a career in big data. So you can just lay out all your questions about your domains, if it is relevant to your domain or not, or if you will be able to reskill and upskill into big data. So if you want to become a big data architect, do attend this session. All right, so the link of this page will also be sent to you. All right, so you can just register over here just with your name, email ID, and your phone number, and you can attend this on 17th May, 7 a.m. All right, and for the US viewers, you can attend it on 16th May, 9:30 p.m. at Eastern Time. Okay. So I hope you all liked this session and you were able to learn about Hadoop. So if you have more queries, of course, you can also go through our YouTube channel.